Welcome back. This is John P. Kelleher with Los Bananas College, and I'm teaching Fire 103, which is Fire Protection Systems and Equipment. I'm now doing part 3, which is fire pumps. And part 2 and 3 are connected, and you'll see that in the quiz. It's all part of it. They're too small items, and we're connected. So know them. Again, part 3. We're talking about fire pumps now. What's a fire pump? Fire pump is the main purpose of fire pumps is to increase the pressure of water to the fire suppression system, i.e. sprinklers or standpipes. What that means is on big buildings is as you flow water, for instance, Home Depot or big commercial occupancy, you can be flowing water through that wet system. Well, the pressure will drop, okay, to a certain point when if it's all the way down the end of the building, or if it's a high rise or whatever, 100 stories or whatever it may be, the pressure will drop. When it drops at a certain pressure, a fire pump will kick in to build up pressure, to supplement the system. And that's what the fire pump is for. And that fire pump is basically made up of, fire pumps are like diesel engines, like a diesel truck, and sometimes 6 or 8 pistons, and they're like a truck, and they're made to build up the pressure. So when the system drops, they build the pressure back up and build up for the system itself. Nfpa 20, know this, Nfpa 20 is the Nfpa standard for fire pumps. Nfpa 20 is the Nfpa standard for fire pumps. The most common fire pump is the electric motor driven fire pump, and most pumps are single stage pumps, usually 5 to 1,500 gallons per minute. Most pumps are single stage pumps, usually 5 to 1,500 gallons, 500 gallons per minute. There are 3 major types of fire pumps. Know them: horizontal shaft, vertical shaft, and vertical turbine. Know that. The horizontal shaft, the most common. The shaft is in a horizontal plane, okay? Vertical, horizontal. So when we talk vertical, up and down, we talk about the horizon, across, okay? So in this case, horizontal shaft, the most common. The shaft in a horizontal plane across the horizon has the pump on one end and the motor on the other. The centrifugal pump has an impeller that has vanes on it to build pressure. As the centrifugal pump turns, it spreads the water out. And I'll go over that further in the lecture. And you'll see pictures of it too in my lecture. By the way, this is also this lecture I'm doing on YouTube. The PowerPoint is on Canvas, downloaded onto Canvas, so you see pictures so you know what a fire pump looks like. The vertical shaft is similar to the horizontal plane. The impeller shaft runs vertically, up and down, and driven by an electric motor. So the vertical shaft, it runs up and down, and it's similar to the horizontal plane, but the impeller runs vertically and are always driven by electric motor. Its main advantage is its compactness. Know that. So vertical shaft, it's compact. Use a lot of vertical shaft fire pumps for like doing wildland firefighting, such. May go over to use it from a lake or a body of water. We'll draw water from there and pump water from there into the where the fire may be. The vertical turbine, last major type of fire pumps. It's used to lift water from a source below the pump, and the vertical turbine also uses an impeller. Okay, and again, I'll go over impeller now that pressure is spread out in just a bit. Booster pumps. The booster pump takes the low pressure municipal water and boosts the pressure to the required for fire suppression. The driver, know that the driver is the source of power that operates the pump. The driver, know that. The 3 types of drivers are electric motor, diesel engine, and steam turbine. The electric motor is the most common and most simple. It's reliable and easily maintained. The electric motor uses the electrical motor with AC, alternating current, and the squirrel cage, because the motor looks like a squirrel cage. The diesel motor is the more expensive and takes more maintenance. That's the second type. And then lastly is the steam turbine, which is rarely used today. So again, the 3 types of drivers: electric motor, diesel engine, and steam turbine. And the driver, know that, is the source of power that operates that pump. Fire pump controllers. It's automatic in operation because it stops and starts by itself. The fire protection system controls it. An electric motor controller is a pressure sensing switch that detects the drop in pressure, which then activates the pump. So just like in your house, where you have a temperature gauge. You have you want the temperature constantly be in the 70s, 68, 70, or whatever it may be. And so if it drops or goes higher, then that system will activate, so it will cool or warm whatever location to keep that temperature gauge, relatively cool or comfortable. So the same thing applies here. If the pressure drops to a certain point, that electric motor pump, a switch will activate to keep that pressure up, so you have an adequate pressure at the end of the line. Testing and maintenance of fire pumps. The fire pumps must be operated regularly, weekly and monthly. Should be checked by the building maintenance people. And then it will show different types of fire pumps. I'll give you examples of that on the some PowerPoints on just like the standpipes, as well as the fire pumps. I'll show some pictures that students did for their oral presentations, so you get an idea what they look like. Okay? But again, I want to kind of go over the impeller. Here's an example of a stationary pump, as one of the students did. See right here, that's a diesel engine. That's the fire pump itself right here. Okay? Just looks like a big engine, diesel engine. Okay? And that builds up pressure. Okay? So as water goes through that low pressure, it goes through this engine, and then as it runs through the impeller, it will build up pressure and spin, and then shoot out the volute, which builds up the pressure of the water as it exits. Okay? And again, there's some examples of what a fire pump looks like. This is the different types of electric motor, okay, the diesel engine, and other types of fire pumps. And again, you'll see in these things, and there's your pressure gauges and everything else. So again, on the PowerPoint, they'll show pictures of this, what it looks like, so you get an idea of what you're talking about. Okay? And I believe that is it for fire pumps. That concludes part 3, okay, on fire pumps. And again, to get a visual, look at the PowerPoints that have been given that have been submitted onto Canvas. But oh, that's right, I want to go over the impeller. Imagine when they talk about pressure, what the impeller is like a tube. As you go through, if you're driving a regular car, okay, and let's talk about the transmission of a car. As you're driving through a car, you turn the key, start it up, and the engine runs and such. Step on the gas to accelerate and so forth. Well, as you accelerate, what happens is the pistons turn, they fire, go up and down, which turns a shaft, okay? And that shaft's connected to the transmission, which essentially turns the wheels, okay? So on an engine, a fire engine, what happens is they set the brakes, set the air brakes, and suddenly they're going in from a regular drive shaft where they're driving the fire engine. Now they're switching from the pump back, they're switching the transmission from drive into pump. So when you take that transmission, now you're no longer you're driving the vehicle, it's set, it's anchored, and now you're going into pump. And now that transmission is still going to spin when you hit the accelerator, which is basically at the pump. And instead of it's still going to spin and such, what's going to spin is, as water enters that volute, it enters the impeller. And as the impeller spins, as you accelerate, it's going to spin. It shoots out that volute, which creates more pressure, and then shoots out the shaft. So originally this water, as it flowing through, that's basically very low pressure, goes through that impeller, goes through that pump as it spins through, and then shoots out at a higher pressure. And that's what they mean by by the impeller. If there's a single impeller, that means what they call a single stage pump. That means one type of pump. If you have multiple stage pumps, that means you have 2 or 3 stage pumps. That could be, more than 2 or 3 or 4. That's what they call a multi-stage pump. So the one impeller means the single stage pump, and the multi means 2 or 3 or 4 impellers. Okay? And again, you'll show a PowerPoint on that, examples of that on the Canvas. Okay? That concludes part 3. Be well.